Hello and welcome to my channel. So let's look at today's daily challenging question 1286. Iterator for combination. The question design the combination iterator class. Combination iterator. Initialize the object with a string characters of assorted distinct lowercase English letters and a number combination length as arguments. Next, return the next combination length in lexicographical order. Has next, return true if and only if there exists a next combination. So the example ABC 2. So it means you need to only return the string with the two letters and also in the order of lexical order. So the first next, you need to return AB, and the second next, you need to return AC, and so on. So and also because ABC only have AB, BC, AB, AC, and BC. So after those are retrieved, then the has next need to be returning false. So the constraint is a combination length smaller than or equal to characters length smaller than or equal to 15. All the characters are unique, and at most 10 to the power 4 calls will be made to next and has next. It's guaranteed that all calls of the function next are valid. So this question, actually we can use the bit operation to do that. So firstly, represent we can use a bit mask. It depends on assume we have n characters in the given string. So we can use a bit mask from the 2 to the power of n minus 1 until 0. The reason we go this direction is we want to get the smallest lexicographical string firstly. So we just loop through to 0. So here we have 2 to the power of n of loops. Then we inside we can check if there are combination length bit set. So we only consider the situation that there are those bits set. So those 000 actually doesn't qualify. I mean, if the combination bit is a 1, then we only consider like a 0, 1, those type of. If it's 2, then we only consider 1, 1, and 1, 0, 1. Those and as such. So how do we get the number of bits in the number in this binary? So we actually there is a Java integer bit count. So this will return the set bit. We can use this directly, and so this one has a. So then the third one is we iterate through n from 1 from 1 through n, and check if the ith bit is set. And so if it is set, then we add to the string. So the fourth step is add the string of this loop to the answer list. Actually, what I mentioned here is the pre-processing. So we get the list of all the strings. Then for the next, we just need to return the string in the list. Here's next, we just check if there is any string left, like we didn't return. So this next and has next both is O1 space. Because we already have the pre-processed. The pre-processed is the more time consuming. So the time will be 2 to the power of n times n. It's the loop at step 1 and step 3. Combine this. So the space, extra space we used is for the list. So actually it's like a CN2. So it's like a C is the combination. How many combinations do we have out of not a CN2 but CN combination length? I mean that's the size of the list. So this is the thought process. Let's start implementing the code. So firstly, let's define this comps. We can call it comps. We define another one global variable called index. And so here we initialize comps. And then also we want to, we can break this to char array, break given. Then also another thing is we want to get the size of this array, which is n. So now we can start doing the beta operation. So as I mentioned, I will go from I1 to the power left shift n minus 1 until 0. So if integer dot bit count of I is not equal to combination length, then we just continue. We don't need to worry about this number. Then if not, then we actually want to define a string builder so that we can add the string to the add the character to the string builder. And then here we go from 0 to n, n minus 1. Then then we actually need to check if I shift n minus 1 minus j is and 1 is larger than 0. If it's larger than 0, means this bit is set. Then we can append this character. So and if it's Otherwise, we don't append. So we just loop through. Then in the end, we add this add the toString of SB to the comps. So then the next is very easy to implement. So first, also we forgot that one thing is we need to set the index as 0 in the here. So then index next plus plus, but we want to return the previous one. So we return the comps dot get index -1. And has next, we can just return index smaller than comps dot size. Yeah, so this one correct. Let's submit it. Okay, so this it means it's working, and so this question is an example of a bit operation or using bit mask to iterate through the through an array for the combinations. So if you have any question, please comment on the below in the video, and otherwise, thank you for watching. See you